Alright, so this is the first demo test of the CandCNC software with the CandCNC Bladerunner system with the Gecko 214V drive upgrade. The parts and prints are in the description below if that's something you're interested in doing. The original issue I had with the camera was at 2,000 steps per revolution, just way too much motor vibration. And you can see that in the line. The line would look like a pure sine wave, just a big squiggle. And you can only see that if you're jogging it manually. As soon as you hit the run, if you could get it to calibrate, it just failed immediately. So I retrofitted in those 214 drives where you can set a higher step multiplier. And right now I got it at 5,000, and it's definitely a lot better. Still a few issues I'm trying to work out, but I'm pretty realistic. If I can get it to within 90%, just a little bit of cleanup, I'd be happy. Mostly just want to use it for something that has a lot of weird geometries, just to save some time with measuring. But I got a test set up here. We scan a hexagon and we'll do a circle and we'll look at the output. So I've noticed, the servo gain feed rate probably somewhere in the middle or below seems to work the best, at least with the steppers. You could probably go higher if you had servos, but anyways, we'll hit the run. And before our 2,000 steps, those motors are really loud, trying to make that small movement. Also with the camera, I noticed you can't even touch the cable near the cable gland on the camera. Just a little bit of movement could screw up the focus, so I put some heat shrink on it and tried to strap it down, but it seems like all those cameras that are like that, they're all crap, so just something I have to deal with. And the other thing I've noticed at the 5,000 steps per revolution, there's a little bit of vibration at the transition points where it's changing direction. I don't know if that's something I can smooth out electrically, either by going with a higher step count or maybe with the XL profile, but it's definitely a lot better than it was before. So I don't know if it's backlash, it's probably everything. It's probably the camera mount, the backlash, just the motor resonance. But the accuracy is really good. Just trying to get those lines. I mean, that's a printed line on a printer, and it's still not straight. There at that transition, you can see a little vibration, which will show up in the output file. But again, this is at 5,000 steps per revolution. I really don't want to go too crazy on that. There's not really much to be gained. Well, I guess you'll lose torque, but still want to get too nuts. I think those drives go up to like 51,200 or something like that. But I might try going up to the next multiplier, which I can't remember what that is, but it's doing pretty good at 5,000. And obviously the best would be servos, but I didn't want to upgrade to that, so. Alright, we'll save it and take a look. See, the straight lines look pretty good, and then the transition points where it's kind of changing direction, at least on the X it seems like it's worse, but you get a little bit of squiggle there until it settles out, and then it's pretty straight again. And the next transition point we got a little bit there, so like I said, it probably is just a backlash and camera vibration and everything working together. But it is pretty close, so if I can get that, something like that, and just clean it up by hand a little bit, that wouldn't be the worst. So we'll do a look at a circle, which is the vibration shows up a little bit more on that. But the motors are definitely a lot quieter with the higher step count, and I've been pretty happy with it. Alright. Definitely somewhere in the middle of the circle, at least on like the bottom half, you can see the vibration more pronounced. And I've noticed that the closer is better. So right now I'm probably 3/4 of an inch above the line. And I got one where I'm about 2 inches above, and the vibrations get more pronounced. So it seems to show up on those arcs where they both have to switch direction quickly. But I could actually trace it, so definitely moving in the right direction. Alright, I'll take a look at that circle. Like I said, it's pretty good. We're at that transitions somewhere in the middle of the circle here. Is where you get the most vibration. But to clean it up, I mean, just quick and dirty. I mean, it is really close. Change the color. I mean, definitely usable. I mean, I still want to clean it up because the head having to follow all those lines, it's kind of hard on the table doing that. But it's pretty good for the first test, I think. Doesn't take too much to get the Gecko 214s to work, to replace those 251 drives. But so that's what I got. That's the first test, and if I play around with it some more, then I'll, if I make it any better, I'll make another video.